destroyed. But what it says here is that the paramagnetism in a metal is nothing to do with the temperature. So how high you increase the temperature of your metal, the paramagnetism itself, but it's not going to be diminished or is not going to be reduced. It's not going to be affected. Why is it important in the industry? If you have a magnetic core and then you apply the magnetic field, then the metal should have a huge magnetism, right? And then you eliminate the magnetic field, the metal should show no magnetism. That's what we want in most of the industrial applications. When you want to pull the car with the magnetic magnets, then you have to use paramagnetic materials, not the ferromagnetic materials, right? So in that case, if you need a high magnetic field, and so you apply the high magnetic field to magnetize the materials, then the material itself will increase its temperature with the magnetic field if you apply high electric field to create the magnetic field, right? So if you apply the high electric field, then your material, your metal, which is supposed to be magnetized, increase the temperature. So in normal case, if you do not understand this paramagnetism in a metal system, which is independent of the temperature, if you don't know this, everybody should be afraid of losing magnetic moment by increasing the temperature. But fortunately, since the metal paramagnetism is nothing to do with the temperature, even if you apply the high magnetic field or electric field to have a high magnetism of the metal, then it's not going to be, the magnetic moment is not going to be decreased because of the temperature. And this is a very important fact. You know. And before the understanding of basic free electron model, everybody thought it's very, very curious. It's a curious thing, you know. But the simple model says it is independent of the temperature, and that is very important. So with the band model, free electron model, we can understand this 5 main phenomena that we can which are really, really useful in modern industries. So we understand that the phenomenon perfectly with this simple free electron model. Next time, we are going to talk about the band. We just talk about the free electrons. Now, in the next week on Monday, we're going to talk about the band. What's going to happen if the electrons cannot have the same energies in one system, according to the Pauli exclusion principle? Then the energy is going to be split to have different 4 quantum numbers. And then it is going to form a band, okay, where the energy difference is just in the order of 10 to the minus 12, something like that. Very, very small, so that everybody thought, before the quantum mechanics, everybody thought it's continuous. But in reality, in the actual theory, quantum theory says it is not continuous. It's a 10 to minus 12 energy gap exists between the energies in one band. But in a band to band, it is a huge difference, and we call that the band gap. So all those things we're going to discuss on Monday, all right? And then I'm going to, guys have answers of your homework? 남아졌니?